In this slidecast, we'll compare the quadratic sorts that we've discussed. So here's a comparison of selection sort, bubble sort, and insertion sort. So notice, in terms of number of comparisons, the best case bubble sort and insertion sort are order n, while selection sort is order n squared. The worst case, they're all order n squared. In terms of number of exchanges, bubble sort is best case when the arrays are nearly sorted or are in sorted order. The other two are order n algorithms best case. And worst case, bubble sort and insertion sort are order n squared, while selection sort is order n. To compare their growth rates, remember for n versus an n squared algorithm versus an n log n. So notice how as n increases and as we double it every time, notice the exponential growth rate. So with n equal 512, n squared is 262,144. N log n is significantly smaller. Insertion sort gives the best performance for most arrays. It takes advantage of any partial sorting in the array, and it uses less costly shifts. Bubble sort is usually the worst performer, unless the array is nearly sorted. Remember, in big O analysis, we ignore constants and overhead. Now, none of the quadratic sort algorithms are particularly good for large arrays when n is over 100. The best sorting algorithms will give an n log n average case performance, and we'll talk about some of them in the rest of the chapter. All the quadratic sorts require storage for the array being sorted. However, the array is sorted in place. Now, there are also storage requirements for some variables. For large n, the size of the array dominates, and the extra space usage is order 1. So we're usually not too concerned about the few extra data items we need to track. Now, in C++, an exchange requires a swap of two objects using a third object as an intermediary. A comparison requires an evaluation of the less than operator or a call to a comparison function. And the cost of a comparison depends on its complexity, but it's generally more costly than an exchange. And the cost of an exchange is proportional to the size of the object being exchanged, so it may be more costly than a comparison for large objects. And that brings us to the end of this slidecast.